Hello everyone. Plan for today is to talk through this concept of an inverse function. Before we talk about how to find one, let's talk about how we recognize whether an inverse will be a function. We can find an inverse without it being a function, but let's talk about how to tell whether it's a function. So in order to do that, we need to go back and review our definition of a function. A function says for every independent variable, there is exactly one dependent variable. For every x in general, there's only one y. Well, how do I test that? If I gave a graph, let's say of a parabola. For every x, there's only one y value. Let's pick this x value out here like at 4. If x is 4, the y value that goes with it is just that point right there. There's nothing else that's on that graph that has an x value of 4. What about an x value of 3? Well, there's just 1 point. What about an x value of 2? Well, there's just 1 point. What would not have just 1 point? How about a circle? What about when x is 1? Well, when x is 1, y could be this point right here, or y could be this point right here. Say like 1, 3, and 1, negative 2. For the same x value, there are two different y values. This is not a function. This is a function. Notice, what kind of lines am I drawing when I'm checking to see how many times the graph has that x value, or has a point at that x value? A vertical line. So a vertical line will test whether a relation, meaning any set of x, y combinations, will be a function where there's only one y value corresponding to every x value. That should be review. Okay. Now, what if I have a graph and I want to see, well, what about the inverse of this function, or the inverse of this relation if it's not a function? Will it be a function? So let's go to our parabola again. We know that's a function, but will the inverse of that be a function? And to test that, we use a horizontal line test. If I can draw a horizontal line through my graph at any point, and it passes through more than once, its inverse will not be a function. We haven't talked about how to find the inverse, but the inverse of a quadratic, let me draw a basic one so I can graph it better. If I draw the parent function quadratic, the inverse of that will look like that. This is a function. This is not a function. If I were to draw a horizontal line that says the inverse of that will not be a function, and it's not. Okay? Vertical line tests whether the given relation is a function. Horizontal line tests whether that relation's inverse will be a function. It still can be a relation. It still can have an inverse. It just may not be a function. All right. So we've talked about this word inverse several times. How do we find one? To find an inverse, we switch the x and the y, and then we solve for y. If it's in function notation, then we use the f raised to the negative 1 power to indicate this is the inverse. Okay? If I wrote find f to the negative first power of x, that does not mean 3x plus 1. 1 over 3x plus 1. Remember how I said back in other videos, 3 to the negative first power is 1 over 3? Not true in function notation. Okay? In function notation, f to the negative 1 does not mean 1 over. Okay, I think I've said that enough times. It does not. Capital N, capital O, capital T does not mean 1 over. It means switch the x and the y and then solve for y. All right, enough of that. So f of x, remember, is y. So when I switch the x and the y, let's put an x here in the y spot, and let's put a y over in the x spot. just take the x out, put y in its place. Take the y out, put x in its place. Another word would be exchange the x and the y. Okay, and solve for y. So x minus 1 equals 3y. Divide, and y equals x minus 1 divided by 3. Or you could write x over 3 minus 1/3. And let's write it in function notation now. Let's put it back in function notation. So f to the negative first power equals x over 3 minus 1 over 3. All right. And the inverse. In all my videos, if you know how to do a problem, hit pause, go try it, and come back, and I'll talk through it. First step, switch the x and the y. Square both sides. Oops, switch the x and the y. Forgot to do that. Square both sides. Subtract 2. Put it back in function notation. Now, that is technically not 100% correct, because if you think back to our square root graph, what does this look like? Just a really small graph up here. It's a square root function, right? Well, if I were to graph this here, it's more than a square root function. It is, shift it up 2, it's going to be my entire quadratic. Well, this up here isn't the entire quadratic. It's just this part over here, switching the x and the y. So technically, I need to say this is restricted to x is greater than 0. Why? Because when we squared, we generated a half of a graph that wasn't there before in the inverse. Okay, next one. Try this one. My guess is you're going to get stuck somewhere, but see how far you can get, and then come back, and we'll talk about it. Okay, first step, switch the x and the y. All right. I have two y values. I need to get rid of the fraction, and I somehow need to get the y's all by themselves on one side of the equation. Well, I'm going to multiply both sides by the denominator. Multiply both sides by the denominator. Why would I do that? Because on this side, a whole number divided by, or as a fraction, is divided by 1. So on the right-hand side, the fraction goes away, and I just get 2y plus 1. On the left side, I'm going to distribute that, and I get that. Next step. I need to put all the y's together on the same side. So we have a choice. We can put them all on the left, or we can put them all on the right. Either one is totally correct. So I'll put them on the left. Why? I don't know. Just feel like it. Next step. I have these two y terms. I need to somehow take the y out of both terms, because there's a y in both, and I need to get them together into a single y so I can solve for that single y. The way I worded that was kind of a big hint. I need to get two terms that have the same y value in it to have only y by itself. Well, I'm going to factor that y that's common in both terms out. There's a y here. There's a y here. I factored it out. It's common in both terms. On the right-hand side, I still have that. I didn't touch that. Well, now, if I had something like 2y, what would I do? I would divide both sides by 2. Well, I have something kind of like that. I have that big mess times y. So how do I get rid of something when it's being multiplied by y? I divide. And I end up with 1 minus 5x over 3x minus 2. Put it back in function notation. I get f inverse of x equals 1 minus 5x over 3x minus 2. Now, some of you, if you were able to cruise through and not have to wait for me, you may have done it different. You may have put the y's on the right-hand side. I'm going to get rid of this right here. At this point right here, you may have said, well, I want to put the y's on the right. And you may have done that. Do it in a different color so we can tell. So I'm going to put the 1 on the left, and I'm going to leave the 2y over here and put the 3yx on that side. Now I'm going to factor out the y. That y is gone. Factor out the y. Divide both sides. And it really is the same as what I have right there. If I were to multiply, let's say over here, if I were to multiply that by a -1 and that by a -1, notice my 5x would become positive and my 1 would become negative, just like I have right there. The 2 would become positive and the 3x would become negative, just like I have right there. So if you are doing problems and like looking in the book or comparing answers with a friend or your tutor or on our homework, the multiple choice, and the answer that you have is not there, try multiplying the top and the bottom of your answer by a -1, top and bottom of your answer by a -1, and see if that gives you one of the answers. Because either one's right, they look a little different. All right, if you did not get that last one, try this one. And if you did get the last one and you're done, nice job. But if you want one more practice one, give this one a try. All right, switch the x and the y. Multiply both sides by y plus 3. Multiply both sides by y plus 3. And I get x, y plus 3x. And I get y minus 1. I'll put all the y's on the right-hand side this time. I get 3x plus 1 equals y minus xy. 3x plus 1 equals y times 1 minus x, because I factored a y out of a y and I got 1. Final answer, y equals 3x plus 1 over 1 minus x. It's back in function notation. Now, if you didn't get that, see if you can multiply your answer by -1. Meaning, if you put the y's on this side, instead of the way I did it, multiply your top and bottom and see if you get what I got. I will multiply my top and bottom to see if you got, whoops, that's a -1, and that would be x minus 1. Did you get that? If so, they are the same answers. All right, that is inverses. Good luck.